So we're going to do some relay wiring today. We've got the SPAL fan relays that are going to go to the SPAL fans. So we've got the wires kind of separated here, and we've got the gray, red, and orange going to one side and then yellow to the other. So we're obviously got two relays here, but the wiring diagram is going to be essentially the same. But what we're going to have is we're going to have yellow here going to the battery positive, which will be fused. Then we're going to have the gray and the orange, and those are going to go to the original fan wires. And then finally red here is going to go to the new fans. So these two wires are the switch wires here. And what happens is they create a switch, power and ground. And then what that does is that it relays power from the battery to the fan, right? So these wires here actually don't really matter too much whether one's power or one's ground. You could really flip-flop these because it doesn't matter so long as it makes a connection here or it flips the switch in here. And so what we're going to do is these two wires, orange and gray, are going to go to the original fan wiring. So how that works is that the factory fan wiring has two wires, and essentially one will have ground and the other will have power when the fan activates, and then it flips the switch inside the relay and then it transfers power. So what I don't know on the FRS BRZ is that newer cars have like staged fans, so like where they've got like a low speed and a high speed fan. With aftermarket fans they don't support that. So I'm going to take a look at the factory fans and then see if it's like a two-stage fan. So to looking at the fans are only two wired fans here. So generally speaking, if it's a stage fan, it will have three wires. But as you can see, these only have two wires. One thing to note too is that this fan right here does not have a pigtail, while this one does. So we're probably going to have to either we're probably going to have to splice these, honestly, just because we don't have access to another connector, unless these two connectors happen to be the same and I can find another one, but we're not going to do all that. One other thing to note is if you look at the fan blades here, so you can see that one side has more blades than the other. So the ones with more blades is your primary fan, and the one with the big blade here is your AC fan. So this fan only comes on when the AC is on. Some cars, like if the temp gets hot enough, it will kick both fans on anyways. So what we're going to do is we're going to note these studs here, and that tells me that the reservoirs on this side, so this is the fan on the right side, passenger side, is the AC fan, while the fan on the left side is the primary fan. And on our fan shroud, I think we actually have the fans backwards, which is not really a big deal. Like I said, we're just going, so long as we know which connector went where in terms of these right here. So we're going to know that the shorter of the two is going to be the AC fan, and we're going to just match it up the exact same way regardless of position of the fan. So for me, the hardest part I think is not the wiring, it's actually the mounting. So there's a couple things that we want to take into consideration here. Is the first one is serviceability and ease to get to. So the thing about it is that this car is like an actual track car, like he's going to be racing it. And so the thing is that things fail, and we're going to need to be able to diagnose it quickly when they do fail. So for instance, like in this scenario here, we put the two relays here because it's easy to get to. We're probably going to put riv nuts into here to actually like have a bolt to hold it in, but he needs to be able to remove the relay, the harness from the relay, and to be able to hot swap the relay. Or the next thing would be like, you know, if the relay does fail, then he could actually just unplug this and then do a hard jumper, and then the fans will just stay running all the time and he's not going to lose out on a track day. So like the thing is that people who've never raced on track before, you have to understand how expensive it is. Like here in Texas, like the average track day starts at about $300. Could you imagine your car starts to overheat because a $3 relay fails and you can't get it, you know, you can't finish out your day? So, you know, you really have to think about just being able to service it on the fly. And sometimes doing that makes more sense to do everything more direct than it will be to, you know, clean it up and make it look nice. So what I mean by that is that, you know, instead of wrapping this all up in tape and everything, you know, we may just leave it exposed, but just route it in a sense where everything is easy to get to and you can quickly diagnose it. So, you know, you could basically just look at this wire, follow it down, and say, oh, okay, here's, you know, it's been rubbing on this and it shorted out and that's why it failed. You know, just things like that. So I think, like I said, this is kind of where our position is going to be, and we'll route the wires onto the other side going to the battery. And so another thing that we also have to talk about too is that this car used to have a battery kill switch, and the battery used to be in the trunk. And there's a good chance that he may go back to that. So what we're going to do is when we do route the wires, we're just going to wrap up the excess and then just zip tie it. So that way, if he chooses to in the future to move it, he's going to have, you know, a lot of wire. It's going to be far easier to cut a zip tie than it's going to be to splice and add wire, right? So that's what we're going to do. So we have this tangled mess down here. It's not actually too bad, but here's the zip tie. And what we're going to do is we're just basically going to pull on it. And you can see that it's going to basically sort itself out. And we get to the end, and we know that this is the red wire that we need for one of the fans. So makes it a lot easier that way. So from earlier looking at the fans, we know that the shorter of the two is the AC fan. So the one with the less blades. So that's the rounded connector here. And then here is the primary fan wiring, which is the squared off connector here. So we'll have to keep in mind which ones we're tapping for what reason. So earlier I said that polarity doesn't matter, and that is true for our application because these two wires, one's going to provide power and one's going to provide ground, and that's going to turn over a relay. However, if you're not running a relay and you wire your fans in, if you get the wires backwards, the fan will run. It just will run backwards. So fans do have a certain way to run forward or backwards. There are fans that can do both, but do keep that in mind if you're wiring the fans direct. Again, with a relay, that doesn't matter, that doesn't apply to us, but that is something to think about. Also, if you want to, usually, if you look at the gauge wiring, usually the ground is thinner than power. I'm not sure what it is in this. Again, I'm not going to check because I don't really care. But, you know, if you don't have like the access to the service manual, there's a good chance, 9 out of 10, that the thicker of the two wire is power. So we're going to work on the AC fan wiring first. And so what we're going to do is, firstly, I pulled up the harness. So the harness used to reside down here, and I pulled it up here. And there, like I said, what our real key is to keep everything tidy, but everything easy to diagnose. Okay. And so now that I've pulled the harness up, we're going to leave it. It's basically going to live right here, so it'll be out of the way of everything, and all the diagnostics should be done roughly right here. So I've cut the orange and gray wire, and we're going to tap it into here. Now, one thing I want to note is you'll see that these two wires are stripped offset. Now, there's a reason for that. We are going to tap them offset, so that way there's zero chance that they could ever touch each other and short out. Now, one other thing that I do want to mention is we are not going to solder these wires. Now, I know a lot of guys say, oh, you got to solder, you got to solder. But the problem with solder is that when you solder a connection, it is going to be brittle. So with a lot of vibration and stuff like that, solder is not the way to go. So what we're going to do is we're going to tap these, and then we're just going to wrap it with some really good electric tape. And then we'll add some strain relief, and then that should be good without any issues there. Okay, so basically you're going to strip these ends. You'll use a pick tool and then just jab a hole dead center in it. When you go to strip the ends that you're tapping into, or when you go to strip the ends that you're using to tap with, you're going to strip these a little bit on the long side because you want it to completely wrap around it. Now, in all honesty, I would have liked a little bit more, but this is going to be a good connection. So at this point, if you wanted to solder it, this would be okay. So you, instead of using like a ton of solder trying to merge two wires together, you would use just a drop of solder, you know, right here, and it'll penetrate through, and then it'll be a good solid connection. Again, if you want to do that, that's totally fine. I'm not going to do it, but either way, you're going to have to add some type of strain relief. So what we'll do now is we'll go to tape this, and what I like to do is just to make the entire thing about 1 inch long, maybe a little bit, but you really want this connection virtually in the center of it, and then it should never come apart. Okay, so like I said, this is roughly 1 inch, and this connection, like I said, is basically never going to come loose. Another thing that we're going to do after we test everything to make sure everything is good and working, we're going to add some strain relief. And what we're going to do, how we're going to do that is simply by taking the wires and then folding it over, right? And so when we fold it over, we'll put a little bit of tape on it just to hold it all together. And what happens is the connection is not the strain, it will be this end right here. So if anything has to move, it'll just move from this end, and then that's going to keep it away from the points that we spliced in. So, and then that'll be right as rain. So we've got the relay wiring tapped over there. It's obviously not cleaned up. We're not going to clean any of that up until we're done testing it to make sure it works. So what we're going to do here is we're going to take the red wire and we are going to tap that into the SPAL fan connector. And so what we're going to do is we're actually going to make that, I'm going to make sure that both the red wires will reach both fans. And the reason why I want to do that is so that way we can hot swap it. So for instance, you know, again, if a relay fails and you have to switch fans like from the AC to the primary and vice versa, you definitely can, and it'll get you through the day. So that's why we're going to make these a little bit on the long side. Got the ends crimped on. I kept this a little long, remember, so that way if anything happens you could hot swap it at any moment. And so I've got to hit it with heat shrink. And so these ends here, you just heat them up and then they have like a goop here. And so I really like these because, like, if done properly, they actually give really good strain relief, right? But for some reason on this end, this is also all from the SPAL kit, you got these, they give you these, and then all of a sudden they give you these. There's nothing wrong with these terminals, you know, like I said, if you crimp them well enough, they're pretty tough. Like, as you can see, the push test here is it's not coming loose, but it's like, why did you give us these that are good and then suddenly give us like these normal ones that aren't so great? And the problem with these is that they pick up moisture and you get corrosion in here and it's just a hot mess, but whatever, it's given in the kit. I don't have any other choice but to use them. Okay, so the ends are the heat shrink stuff is on all ends, and now it's just a matter of plugging it up and grounding everything, wiring the rest of the way up. So the only connections that we need to make that are left are going to be the 2 grounds for the fans themselves, and then basically the 2 power wires here to the battery. And at that point it should work. So one thing I do want to mention though about these grounds. So a lot of the stuff that needs to be serviced on the FRS requires removal of this. So what I'm going to try to do is actually ground these somewhere along here. As you can see, like, just to do like the intake, this piece comes off. And so that tells me that this really is not a great ground, just because that it's grounded by bolting it in. So I'd much rather ground it to something along here that has like tack welds on it. So and I left enough room here to do so. So even if it's just temporarily for testing to make sure that the fans operate as they should, but that's basically it there. So that's done. Well, I lied, it's not done. It's usually helpful if you put the fuses into the fuse holders. And so we're given 240s and 230s. So I'd like to use the 230s as first, just to be on the safe side, and then if it pops, we'll switch over to the 40s. And the reason is that 30s are way easier to obtain than 40s are.